Now we will verify the law of parallel using meter bridge. In parallel, we know that the net resistance goes to the least value than the resistance out of which one is the least. That means here this is 20 ohm, this is 10 ohm. The resultant value of the resistance in parallel should be less than 10 ohms. So in order to connect them in parallel, we had connected two wires to resistance 1, which is of 20 ohms, and two wires to the resistance which is of 10 ohms. Now in parallel, the net effective resistance theoretically will be R1 R2 divided by R1 plus R2, and so it is 20 into 10 divided by 20 plus 10. So approximately the answer turns out to be 6.66 ohms. So let us connect them in parallel. So connect them in parallel. End-to-end connections to be made. Take the first wire of resistance 1 in your hand and the first wire of resistance 2 in your hand and connect them. Similarly, the resistance 1 second terminal and the resistance 2 second terminal to be connected. Now both these resistances now are in parallel with each other, and connect either in the left hand gap or a right hand gap. Now we are aware of the theoretical resistance in parallel. It is 6.66 ohm. So the values taken from the box will be in that order. So let us take first value as 5 ohms from the box. Now tap the jockey on both the sides of the meter bridge and check that the galvanometer shows a deflection on both the sides of the scale. Now tap at different points. So Lx is now 57 and Lr is 43. Let it make 6 ohms. We make it at 6 ohms now. So the resistance taken from the box is 6 ohms. As R increases, Lx should decrease. So the value of Lx has decreased to 52. Lr has gone to 48. And the third reading will be taken at say 7 ohms. So now Lx is 48.5, Lr is 51.5.